Okay, let's look at section 9.7 where we're going to be graphing and solving linear inequalities. And our objectives are going to be to graph inequalities on a number line. That'll be pretty simple. And we're going to learn how to solve linear equalities, and pretty much that'll be exactly like solving regular equalities, except the sign will be an inequality sign. So let's just review really fast our inequalities. So we have four possibilities. We have A, A is less than B, A is greater than B, A is less than or equal to B, A is greater than or equal to B. And over here I'll give some examples for each one of these A's and B's where each one of these are true. 7 is less than 10. 11 is greater than 5. 3 is less than or equal to 7. 7 is greater than or equal to 7. So remember these signs right here with the extra little bar, and you can draw them this way if you wish instead of kind of along the diagonal. They're the same. That means, for example, A is less than or equal to B means two sentences. It means A is less than B, that's one possibility, or the second possibility, A is equal to B. So this symbol right here combines these two possibilities into one symbol. So let's go and let's solve a problem. It'll probably be the easiest way just to look at a particular problem and start solving it. So our first example is we're going to graph inequalities. So these aren't equalities, but they're inequalities. So I'll write, it's not really good typesetting on the part of whoever made these worksheets, so I'll write these. The first one we're going to do, which is A, states X is greater than or equal to minus 5. So there's an awful lot of numbers X that's true, that makes this a true statement. X, if X is 5, then that's a true statement because 5 is greater than or equal to minus 5. Indeed, X is equal to minus 5 also makes this a true statement because minus 5 is greater than or equal to minus 5. 0 also, if X is 0, that also is true. So there's just an awful lot of possibilities for this particular possible values of X that make this statement true. So what we do is we graph all of those possibilities on a number line. And we divide our number line right in the middle. We put 0 right here. Numbers that are greater than 0 go on the right side. And on the left side, over here, are numbers that are less than 0. So what we want to do in this case, let me get me some room here. After I've showed you that, I'm going to go back to my number line that I've drawn. And since you're going to be taking your exams in my math lab, they will already be drawn for you, a number line of some sort. If we were taking them in class, I would also have them drawn for you. So just remember that 0 is right here. So minus 5 is less than 0. So it's a negative number, and negative numbers are on the left-hand side. Positive numbers are on the right. So these are all negative. These are all positive. 0 is neither negative or positive. It's the dividing line between the two. So I want some way to include, I want to find or graph all numbers that make this inequality true. And we already found some of them. And one of those actually includes minus 5 as a possibility. So what we do is all of the numbers greater than 5 work. So this is what I tell students to do. Just use a marker or just color it in. But I want to tell you that minus 5 itself also works. So to include minus 5 in, I draw a circle, and to indicate that 5 is included in the set of solutions that make that inequality true, I circle it in. So this number line with the orange color here basically are all numbers x greater than or equal to minus 5. So those are all numbers that make this particular inequality true. Okay, so let's keep that in mind and let's do the next one. So these first two are really just how to graph on the number line. So again, I want a number line. Doesn't have to be elaborate. And to be honest with you, I don't even care if you divide it right down in the middle with 0. But our next inequality, number B, is the one we're doing, states we want to find all numbers y that are less than 7. So what I need to do is decide where I want 7 to be. You don't have to worry about scale. So there is 7. And then I want to indicate all numbers that are less than 7. So less than 7 doesn't include 7. So I'm going to start right here, right on top of 7, and I'm going to draw a circle. And I'm not going to fill in that circle. And then I'm just going to fill in going to the left of 7, scribbling it in like this, all the way till I get to the end of my drawn number line. And this indicates that my solution set, these are my numbers y, this is where they live, all numbers less than 7, or numbers to the left of 7, but not including 7, that's what the open circle that's not filled in means, makes this particular equation true. Okay, so let's look at another example. So our next example is C. And we have minus 3/2 is greater than or equal to m. So that's another way, this is another way of saying, and it's good to be able to go back and forth, that m is less than or equal to minus 3/2. And this is what I will encourage you to do. If you're given an inequality sign that points to the right, just move everything around so that you have the exact same statement, with the inequality sign pointing to the left. And the reason is when I draw my number line, that's the natural direction of pointing. Because if A is down here and B is up here, then we have that A is less than B. So let's actually, in this case, all we have to do is find where minus 3/2 is. And I'm just going to say minus 3/2 is right there. And this includes all numbers m that are less than or equal to minus 3/2. So every choice of m that is less than or equal to minus 3/2 makes this statement a true statement. So that's what I want to plot. So again, I come over here and I grab, and I want to include minus 3/2. So I put my circle right there. And m is less than minus 3/2 or equal to minus 3/2. So I shade it in. I shade in the circle. That indicates that minus 3/2 is included. And then I just indicate all of the numbers less than minus 3/2, including minus 3/2 itself, make the statement true. So that's where my values of m live that make this particular equation true. So those are three really good examples on how to graph inequalities. And you'll be using inequalities and graphing inequalities all the way through. They have a lot of uses in mathematics. So let's do number D. Number D says minus 5. We have this, and I've got to show you what this means. So this is called a compound inequality, and there's two ways to read that. And I think the best way to read it is this way, that t is greater than minus 5 and t is less than or equal to 0. So that's what that symbolism means. That you just look at, for example, this part right here. And then, for example, including the t, this part right here. And you get two inequalities. You have one, that minus 5 is less than t, and then you have to remember to write and. Let's get some more writing space. So here I'm going to draw my number line. You can draw it as long as you want. Of course, you won't be drawing this at all. And I have to have 0 and minus 5. So literally, you can put 0 anywhere you want. And you don't have a choice as to where minus 5 is, in the sense that once you've decided where your 0 is, your minus 5 has to be to the left. So let's graph the fact that t is greater than minus 5 but less than or equal to 0. So t can actually be 0. 0 is included, so I'm going to color it in. But it has to be greater than minus 5. So minus 5 isn't included. So it's all of these numbers in between those 2 points. So if t lives in this area, that means t is greater than minus 5, but less than or equal to 0. So all of these numbers that I'm indicating graphically by shading them in make this a true equation. And that's what this is about, is graphing the solution sets to linear, I said equation, I said it should have said inequality. This whole thing is about graphing solutions or solution sets to inequalities. And almost always there's an infinite number of solutions to a given inequality. Sometimes there's only one, that's kind of rare, and sometimes there are none, but for the most part there's an infinite number. So now we're actually going to be given, we have to solve. We're going to solve and graph. So here's the thing about solving linear inequalities. You proceed exactly as if the inequality is an equal sign. The addition principle works completely as normal. In other words, here is the addition principle. Of inequalities. If A is less than B, then for any number C, we have A plus C is less than B plus C, and, or if you want to use the word or, A minus C is less than B minus C. So what I'm telling you here is that if you have an inequality, you can add the same number to both sides, or you can subtract the same number from both sides. In this inequality, that stands in, I can replace this sign, which is less than, with greater than, less than or equal to, or greater than or equal to, and the principle holds. So that's pretty much going to be the principle that we're going to use to solve these. So let's do 2a. We have x plus 7 is less than or equal to 12. Well, again, I want to get x all by itself. So I'm going to take 7 and move it to the other side. And the price you have to pay is it becomes negative. So this gives me x is less than or equal to 12 minus 7. And just simplifying the right-hand side, that gives me x is less than or equal to 5. And we want to graph the solution set, so I'm going to graph it right over here. I'll say 0 is right here, and 5 is right here. And x is less than or equal to 5. So when I grab I'm going to include 5 in my solution set. I'm going to scribble that in, and it's going to be all numbers less than 5. So any x that lives in this area makes this equation true. So this is a graphic representation of the solution set to this linear inequality. Okay, I kind of want to leave maybe this over here. I don't know if it's needed or not. You probably have had time to digest it. Literally, we've been using this exact same property for solving equations repeatedly And we're going to just use it again quite liberally in solving these linear inequalities. So now let's do 2b. So I have x minus 10 is greater than minus 3. Again, I want to isolate x. So I'm going to take my minus 10 and move it to the other side. And the price I pay is that minus 10 must change sign. So I get plus 10. So that tells you x is greater than minus 3 plus 10 is the same as 10 minus 3. So x is greater than 7. So what I'm going to do is I'm going to rewrite this. That's the same thing as saying 7 is less than x. I think if you write it this way with the inequality pointing to the left, when we go to graph it, you won't make as many errors because it's the natural direction. So I have to find 7 on my number line. So I'll put 0 way down here, and I'll put 7 right there. These are arbitrary choices. You just decide. And x is greater than 7, but does not include 7. So that means I don't include 7, so it's an open circle. And then x is greater than 7. I just color it in. So any x values that live here make this a true equation. So this graphically represents the set of numbers that makes this, I said equation again, it's so easy to say that, make this inequality true. It's the habit of the mind and the habit of the tongue. We say equations so many times in algebra that when we switch to inequalities, equation just naturally wants to come out. So let's do 2c. So I have minus 4z minus 2 is greater than minus 5z plus 1. So the first thing I'm going to do is I'm going to move the 2 to this side. So the minus 4z is going to stay there by itself. And I'm going to leave the minus 5z exactly where it is. Plus 1 is already there. And the minus 2 being moved to that side changes its sign and becomes plus 2. Then the second thing I'm going to do is just simplify the right-hand side. Now I'm almost there. This time I'm going to take the minus 5z and move it over there. And when I do so, it becomes plus 5z. Now I wrote plus 5z, but you don't have to, and often we will not. Is greater than 3. And when I simplify this, that becomes 5z minus 4z. That gives me a z is greater than 3. So notice I just kept the same exact direction of the inequality all the way to the last step. But now at the last step, I'm going to rewrite it and say that 3 is less than z. Notice these are exactly the same things. To say that z is greater than 3 is the same thing as saying that 3 is less than z. And we have to graph our solution set. So here's my number line. And I need 3 on it somewhere, so I'm just going to arbitrarily decide where to put 3. And my numbers z that make this true are larger than 3 but do not include it. So to indicate I do not include it, I put the open circle and then just shade the area to its right. And you don't have to write this, but I'm just doing it to explain. If z lives in this area, then that value of z makes this this inequality true. So again, this is a graphical representation of the solution set of this inequality. Okay. So now I'm going to introduce another principle. And this is really easy to remember as far as conceptually remember, but it's easy to forget to do. So the rule is easy to remember, but sometimes it's easy also to forget to do. So this is the multiplication property of and I'm not going to write this out formally. I'm just going to tell you what to do. If you multiply, which also implies divide, both sides because you always have to do it to both sides to maintain the inequality of an inequality, by a negative number, then you must change the direction of the inequality. So I'm going to give you an example. Suppose we have minus x is less than 7. Well, I don't want that minus on the x. So one way I can get rid of it is I can multiply both sides by minus 1. So when I multiply minus x by minus 1, I get x. And when I multiply 7 by minus 1, I get minus 7. But I just multiply both sides by a negative number, so I have to change the direction of my inequality. You cannot forget to do that. If I have minus 2/3 is less than or equal to minus x, I can make the x positive by multiplying both sides by a negative. So that's going to give me a 2/3 on this side and an x on this side, but I have to flip the direction of the inequality. Now the nice thing about it is there's always ways that you can just use the addition property. Right here, I will use the addition property to fix this. I have minus x is less than 7. So if I move my minus x over here, a 0 is left behind, and x becomes positive. And now if I move my 7 over there, then I have 0 minus 7 is less than x. So I get minus 7 is less than x, which is exactly what this says. This says x is greater than minus 7, which is exactly the same as minus 7 is less than x. So I guess all I want to say is be very careful when you're dealing with negatives. If you have a negative coefficient to the unknown. So that said, the best way to do it is just go some examples. And just recall that we have many different ways to take care of this. I want some space here if I can have it. There we go. So this is 3a. So I have minus 8 is greater than or equal to x over 3. So we're going to do the exact same thing. You can just pretend like this inequality is an equal sign. So I want to clear the denominators. I only have one denominator, so that's 3. So I'm going to multiply both sides by 3. Now notice, that's a negative 8, but I'm multiplying by a positive number. So there is absolutely no need to flip the direction of this inequality. So 3 times minus 8 is minus 24. So that's minus 24 is greater than or equal to x. And you can write it the way I prefer it. You don't have to, but I prefer always to write it this way, especially if you're asked to graph it. And we are asked to graph it. So let's draw the number line. And I have to find minus 24, and I'm going to put it right there. Then I'm going to say 0's up here. And x is less than or equal to minus 24. So x is less than or equal to minus 24. That means minus 24 is included, so I fill it in with the solid circle, and then I just indicate that the values that make it true are values that are less than or equal to minus 24. And you're done. And in my MATLAB, I'm not for sure that I've seen how my MATLAB requires you to do that. So you'll just have to read the instructions when you're doing your homework, is to know how to fill in the number line the way my MATLAB wants you to. Okay. So I think this next one would be a good one for you to try to do on your own. So we're doing 3b. And it's 3x is less than 73. So again, we solve this one just like it were an equation. We divide both sides by 3 because that's the coefficient of x. I know how many 3x's are, or what 3x is less than in this case. So if I divide both sides by 3, I'm done. Now here you're asked to graph the number on the number line. Now I'm absolutely fine with this type of a solution. 73 is not evenly divisible by 3. It doesn't pass the division test because 7 plus 3 is 10, and 10 is not evenly divisible by 3. But I want to graph it on the number line, and I kind of want to know where it is. So you have two options. You know it's positive, right? So you can say right there is 0. Right here is where I say 73 divided by 3 is. And the values of x that make that true are values of x that are less than that, but do not include it. And you can just do it exactly like that. Or if you want, you can go ahead and divide 73 by 3. So it's 24 1/3. And you could come over here and write instead 24 1/3. Especially if you had to find, okay, here's 25, here's 24, here's 26. Where does it go? You would actually need to do the division and get the whole number part in order to situate it on the number line. For my test, if we were actually giving you the test, the reason I'm telling you this is I'm not really for sure how my math lab is going to ask you to do it, and you're going to be taking the exams on my math lab. So that's the reason I told you you might need to do that extra step. So let's go ahead and do another problem. This is going to be 3C. And it's 0 is less than y divided by 8. So again, we're going to clear the denominators by multiplying both sides by 8. Now 8 is a positive number, so it doesn't matter. So 8 times 0 is less than y divided by 8 times 8. But 8 times 0 is just 0. And y divided by 8 times 8 is just y. So this tells me y is greater than 0. So to graph it, put a 0 right there and indicate that values of y do not include 0 itself, but values greater than 0. Okay. And one last one on problem 3. Let us do it. So I'm going to do 3D. 3D is minus 3/5 z is less than or equal to 9. So again, I'm going to clear the denominators. There's only one denominator, so I'm going to multiply both sides by 5. So when I multiply minus 3/5 times z by 5, it clears out the 5s, and I have minus 3z. And that's less than or equal to 9 times 5 is 45. So I'm going to move this on up. Let's concentrate on this step right here. So now what I want to do is I want to divide both sides by minus 3. So because I want a positive z here. So let's go ahead and divide both sides by a minus 3. When I divide minus 3z times minus 3, I get z. And then I'm going to divide 45 by minus 3. And I'm just going to leave it in that form for right now. And I can't just copy down the inequality. I just divided by a negative, so I have to change it. And over here you want to simplify this, and you want to divide because 45 is divisible by 3. Why? Because 4 plus 5 is 9, and 9 is divisible by 3. So that's 1, 3, 15. So z is greater than 15. Let's do it another way. So we have is an answer. When we divide it by a negative, we got that z is greater than or equal to 15. So now let's actually start back. Right here and approach this another way. Let's switch sides. I'm going to put my minus 3 on this side and my 45 on the other side. When my 45 moves to the other side, it becomes minus 45. And when my minus 3z goes to the other side, it becomes plus 3z. Notice this did not involve multiplication. This is just moving terms across the division sign. And we've always switched the signs when we do that. So again, now I can just divide both sides by 3. And we just discovered that minus 45 divided by 3 is... Did I skip? This is supposed to be a minus here. Sorry. I was supposed to divide 45 by minus 3, and I forgot to carry over my minus. Yeah, I'll eventually catch it. This is 45 divided by minus 3, and which is minus 15 is less than or equal to, and that's supposed to be, at least that's an understandable, because a 3 almost looks like a z. That should be a z there. There we go. So z is greater than or equal to minus 15. Z is greater than or equal to minus 15. So we got the same exact answer. Let's go ahead and graph that on our number line. So I need to just put down a 0. And somewhere minus 15, and I want to indicate that z is greater than minus 15. So I'm going to indicate that by filling in the circle, and then I'm just too lazy to grab another color. And most people, when they take tests, they do this with pencil, or they don't have extra colors, so I just tell them just to indicate where z lives, and that is where z lives. And what do I mean by that? Values of z in that area, and that of course goes on to positive infinity, make this equation true. Okay. Oh. So we have some more. So I'll have to write these out for you. They're really not that easy to see. They're images is what they are. So I'm on 4. I can make this go up one more. 4a. So it's 3 times 3x minus 16 is less than 12 times x minus 2. So let's get us some space here. So again, we just use, we're just going to pretend like this is an equality. Instead of an inequality, you just pretend like it's an equality. And the only time you have to worry about it is if you have to flip it. And if you don't have to flip it, you just write it down in the same direction till the very end. And in the very end, if it's pointed to the right, you can just change the things around so it's pointed to the left if you want to. You don't even have to. So 3 times 3x is 9x. 3 times minus 16 is minus 48. 12 times x is 12x. And 12 times minus 2 is minus 24. So I'm going to move my 48 to the other side. Now I'm going to move, I'll just do this step at a time. So that's 9x is less than 12x. since my 48 is getting moved to the other side, it has to change its sign. And it was minus 48 on the left, so it becomes plus 48 on the right, minus 24. So as always, we're going to collect and simplify like terms. So this gives me 9x is less than 12x, and 48 minus 24 is 64. There's an x right there. So now I'm going to move my x term to the other side. Or do I want to do that? Let's stop and think. If I move the x term to the other side, it's going to be negative, and I'm going to have to divide through by a negative, because I'm going to have minus 12x plus 9x is going to give me a minus 3x. So I'm going to abandon that particular idea, and instead of moving the 12x, we have choices, don't we? I'm going to move the 9x over here. So when I move the 9x, 0 replaces it. And I have 12x minus 9x. And it's joined by a 64. Now that 64 is not going to stay there. Let's go ahead. That's 0. 12x minus 9x is 3x plus 64. So now I'm going to move my 64 to the other side, and it becomes negative. So 0 minus 64 is minus 64 is less than 3x. So coming up over here, I'm going to divide both sides by 3. 3 is positive, so I don't change the direction of the sign. 3x divided by 3 is x. Minus 64 divided by 3 is minus 64 divided by 3. And this does not simplify where we ask to graph the solution. Yeah, we have to graph the solution. That's okay. It's not a problem. So all I have to do here is just show that I know where things go. There's my 0. And I'm going to say down here is minus 64 thirds. Now if you want, you can actually divide that out and write it as a decimal with a fractional part. I wouldn't write it as points. I would just do the remainder over 3. And x is greater than this number. So the values of x that make it true are the values of x that are greater than minus 64 divided by 3. So I don't fill in that circle, but I do fill in this direction because it's x greater than that value. And any x that lives here where I've shaded in is a solution to this equation. Okay. Oh, goodness. Okay, everyone's screaming at me, right? I hear you screaming. I've slowed down and I just see my error, and all of you are seeing it too. This is not supposed to be 64. This is 48 minus 24 is 24. Yeah. So I don't even sweat when I make mistakes like this, because I think I mentioned it to your class before. At the end of working any problem, you should glance back over the problem and see if you made any errors. And that's exactly what I just did, is I glanced back over to see if I made any errors, and I noticed immediately that I made an error right there. You know, you're talking and writing, and that's what happens. So we're fixing that error. And it's a pretty easy fix. But this is, if you feel like you understand the concepts in math, but you're not getting the best grade, you're making little errors. And I'll be honest with you, when I went back to grad school, I made a lot of little errors. It was very aggravating because I studied really hard, and conceptually I knew what I was doing, but I would make errors just like that because I was going fast, and many times I didn't have time to go back and look over. But if you do have time to go back and look over, always do so. In this case, minus 24 divided by 3 is minus 8. So that's what we would want to write there. We would want to write minus 8 rather than minus 24 divided by 3. Many times I will have my work solutions here next to me, so I can glance over at them really fast. I don't have them right now, but we'll get through this. Let's go ahead and do number B. So this is 4B. So this is minus 18 times Z minus 2 is greater than or equal to minus 21Z plus 24. So again, we're going to use distribution. Minus 18 times Z is minus 18Z. Minus 18 times minus 2 is plus 36. And this is minus 21Z. And this is plus 24. Now this is what I think we're going to do from now on. This is the strategy I do, and sometimes I don't know if I should sometimes tell you exactly what I do every time, because the way I do it may not be the most efficient way. But I think avoiding multiplying or dividing by a negative is always desirable, because I see so many errors. Students do everything exactly right, then they divide or multiply through by a negative and they forget to flip the sign. And we can usually avoid that altogether. Not always, but usually we can. So since 21, minus 21 in absolute value is greater than minus 18 in absolute value, I'm going to take care of the variable terms first. And I'm going to move minus 21Z over to here. So in doing so, it changes sign. So I have 21Z minus 18Z plus 36 is greater than or equal to 24. 21Z minus 18Z is 3Z plus 36 is greater than or equal to 24. So now I'm going to take the plus 36 and move it to the other side. So that's going to give me 3Z is greater than or equal to 24 minus 36. So that is 3Z, doesn't look much like a Z there, is greater than or equal to 24 minus 36 is minus 12. I don't really like that Z. I started to write the inequality and realized I needed to be writing a Z. So let's write the Z right there. So guess what? I don't have to worry about flipping the inequality because I'm going to divide through by 3. That was the whole reason I made this move right here and moved the minus 21 over. When I divide both sides through by 3, I get Z is greater than or equal to, and minus 12 divided by 3 is minus 4. So let's go ahead and graph that on the number line. Here's my 0. Here's my minus 4. And I like to write it this way. Minus 4 is less than or equal to z. Notice how the minus 4, and it tells you exactly which side the z is. And in this case, it's less than or equal to. So that means the circle is filled up. And it's all of these values up here. And that's where my z live that make this equation true. So again, this is the graphical representation of the solution to my original equation, which was this equation right here. So let's do one more. And this is a good one because it requires us to use the principle of clearing denominators. So this is 4c. And it's 8 over 21 times x plus 2 is greater than 1/7 x plus 3. So our LCD of our denominators, 7 and 21, it's always greater than or equal to the largest of the two numbers, and it's equal to the largest of the two numbers if the smaller of the two evenly divides the larger of the two. So that's my LCD. So I'm going to multiply both sides by my LCD. My LCD is positive. That's great. There's no flipping of inequality signs. So 21 times 8 divided by 21 times x plus 2 is the same as 21 divided by 21, which is 1, times 8 times x plus 2. So this is 8 times x plus 2. And that's greater than 21 times 1/7 times x plus 3 is the same as 21 divided by 7, which is 3, times 1, which is 3, times x plus 3. So 3 times x plus 3. So now we use distribution. 8 times x is 8x, plus 8 times 2, which is 16, is greater than 3 times x, which is 3x. 3 times plus 3 is 9. So again, I'm going to look at the variable terms, and I'm going to move the smaller of the two in absolute value over. So I'm going to 8x minus 3x plus 16 is greater than 9. So let's finish it out over here. So 8x minus 3x is 5x plus 16 is greater than 9. So now I'm going to move the 16 to the other side. It becomes negative. So that's 5x is greater than 9 minus 16 is minus 7. So I'm going to divide both sides by x. So both sides by 5 rather. And that gives me 1x. So the answer is x is greater than minus 7/5. So let's just check our work. 821, x plus 2, 1/7, x plus 3. LCD is fine. 8 times x plus 2, 3 times x plus 3. 8x plus 16, 3x plus 9, 8x minus 3x is 5x, 9 minus 16 is minus 7, so that should be correct. And let's graph that solution. Again, our number line. And it says x is greater than minus 7/5. So I'm going to come over here, and I'm going to find where minus 7/5 is. I'm just going to say it's right here. And I'm going to rewrite that as minus 7/5 is less than x. So that means that 7/5 is not included, so we don't fill in the circle. And the x that live in this shaded area is the graphic representation of the solution set to this inequality. So now we have some reading problems. Oh, just one reading problem, and we'll be done. Is it going to give me yellow? So this is 5. A, there's no B. So 8 more than twice a number is less than. So twice a number. So let's do this direct translation. 8 more in this case is an indication that you're adding. Twice a number. Well, let's let our number, our unknown number, be x. So twice x is less than negative 12. Find all numbers that make this statement true. So we're just doing, now that we've got the inequality, we're set. So I'm going to leave my 2x exactly where it is. And I'm going to move 8 to the other side. And in doing so, it becomes negative. So this gives me 2x is less than minus 20. So I'm going to divide each side by 2. And that gives me x is less than minus 10. Now it doesn't ask us to graph it, but we've been graphing all of them, so we might as well. Here's 0. Here's minus 10. And x is less than minus 10, so it does not include 10. So I just put the circle there and I don't fill it in, and I scooch all this way down there. And again, you don't have to write the x and point down there. I'm just doing it to tell you that this is the graphic representation of all numbers x that make this inequality true. Okay, so that's it for this particular chapter section. I think it was section 9.7. Indeed it was. So just listen if you have any questions about any of this. If I made an error and you want to point it out to me, just shoot me up with an email. And until then, keep on studying.